A source map. That's the whole failure. One misconfigured publish, and 512,000 lines of Claude Code's actual source code sat exposed on the public NPM registry, version 2.1.88. Nearly 2,000 files. A researcher named Keofan Show posted the link on the day it happened, and it pulled something like 27 million views before anyone could pull it back. People assumed they were about to find the trick, the secret prompt, the hidden model, the one weird technique. That's not what's in there. So this is what actually leaked, and it's duller than anyone wanted. A while loop. It calls the model asks for tools, the harness runs them, the results go back in, and it repeats. That loop is maybe a few hundred lines. One community teardown of the extracted code put the actual AI decision logic, the part where the model reasons, at something like 1.6% of the codebase. The other 98% is infrastructure, permission checks, context math, recovery code for when a request fails. So if you built your own agent loop this weekend and it's already falling over, this is why. You built the 1.6% and skipped the part that was never optional. Here's the spec that actually matters, and it's not the loop, it's what feeds it. The context window, which is just the fixed amount of text the model can see in one call, is the thing every long-running agent eventually runs out of. A researcher team out of Mumzai's Vila lab, led by Ziqiang Shen, pulled the extracted source apart and documented 5 separate systems that run before every single model call just to keep that window under control. One trims oversized tool output. One snips old history. One does lighter compression when the cache overhead gets heavy. One projects a shortened read time view over the full transcript without ever deleting it. And only when all 4 of those aren't enough does the 5th kick in, an actual model call that summarizes the conversation down to fit. 5 layers, cheapest first, and the expensive one only fires as the last resort. Most people building their own version skip straight to that last one. They hit the token limit, and their entire strategy is call the model again and ask it to summarize itself. That's the naive version, and it fails quietly. You don't get an error. You get an agent that's technically still running, holding a fuzzy summary instead of the actual file it read 4 turns ago. And you spend the next hour wondering why it just reintroduced a bug it already fixed. And the leak didn't just expose plumbing. Buried in there was a whole subsystem people started calling undercover mode, built to stop the model from leaking Anthropic's internal project code names while it's out there contributing to someone's open source repo. One line from the injected instructions got quoted everywhere. Do not blow your cover. Funny detail. Also a reminder that a harness isn't just loop plus tools plus memory. It's dozens of small specific patches for situations someone actually hit in production, and you will not think of most of them until they bite you. Now, the honest part, because the leak itself is a mess, and the stories got real asterisks. This wasn't a design document Anthropic published. It's source-level analysis of code the company didn't intend to release, and a spokesperson confirmed the exposure was human error, not a breach of anything sensitive like credentials. So every specific number here, the tool count, the hook count, all of it, traces back to one snapshot of one version. It's probably already stale, and a Korean developer named Sigrid Jin ported the architecture to Python from scratch within hours, called it Claude Code, and it crossed 30,000 GitHub stars faster than almost anything on the platform ever has. Worth saying plainly, a clean room port of the shape of a system is not the same claim as running the actual thing. So who this is actually for? If you're scripting something for yourself, a one-off that reads a folder and writes a report, none of this matters, and building a 15-line while loop is the correct move, not a mistake. But if you're shipping an agent that touches someone else's files, runs shell commands, or sits in front of untrusted input, the honest fork is this: you need layered permission handling before you need a better model. The extracted source shows 7 separate permission modes: deny rules that always beat allow rules even when the allow is more specific. And Anthropic's own auto mode research found users approve about 93% of permission prompts without really reading them. That's not a compliment to the users, it's the whole reason the system doesn't trust a human dialog box as its only safety layer. Sandboxing runs underneath the permission check anyway, isolating what a shell command can touch regardless of whether a person clicked approve. And to be fair to the alternatives, not everyone solves it this way. SWE agent and OpenHands wall the whole agent inside a Docker container instead of checking individual actions. Aider leans on Git, treats every change as reversible, and calls that the safety net. Neither is wrong. They're just answering a different question at a different cost. Security researchers looking at the leaked sandbox code found its own crack, too. Commands with more than 50 subcommands skip the granular check entirely and fall back to one generic approval prompt, because parsing each one individually was freezing the interface. Layered defenses only hold if the layers don't share a failure mode, and here, 2 of them briefly did. The subagent piece is where most home-built versions really show their age. Spin up a helper task in a typical DIY setup, and it usually just appends its whole transcript back into your main conversation. In the real thing, a subagent gets an isolated context window, does its work, and returns a summary only, its full transcript stored off to the side in its own file. Your main conversation never sees the subagent's scratch work. That one design choice is the difference between a system that can delegate 10 small tasks in a session and one that quietly runs out of room by the 4th. So here's where I land. The leak itself, forget it. It's a legal mess and a stale snapshot within a year. The thing it proves is what's real. Almost none of what makes this reliable is the model being smart. It's the boring deterministic scaffolding around it, the layers that catch what the model gets wrong or forgets, running the same way every single time regardless of which version of Claude sits inside the loop. What to watch? First, whether Anthropic ships something like an official architecture doc off the back of this, instead of leaving the only detailed account sitting inside an unofficial paper built from a leak. And second, whether Claude Code and the other clean room ports can actually hold up their own compaction and permission layers over time, or whether they quietly regress to the naive version once nobody's watching closely. It used to be a question of whether your agent could call a tool at all. Now it's whether it can still tell the truth about its own context on turn 80.